Welcome students. In this video I will discuss about the topic transformation of sum and products. Okay, transformation of sum and products of trigonometric functions. So the thing is, through all the topics of trigonometry we are doing what? We are just extending our knowledge and concept in the field of trigonometry. So in the first topic we learned how to find the values of trigonometric functions for some obtuse angles like sine 120 degree, cos 120 degree and greater than that angles, isn't it? And using the concept of quadrant we have found that cos 120 degree, sine 120 degree, that kind of obtuse angles, values of trigonometric functions for that obtuse angles we have found using the concept of quadrants. In the second topic we have learned how to find the values of trigonometric functions for some acute angles which are not known, like 75 degree, 15 degree, isn't it? We have splitted 75 degree in terms of two known angles 45 and 30, 45 plus 30. We have splitted 15 degree in terms of two known angles like 45 minus 30 or 60 minus 45. In that way, by splitting up the acute angles, unknown acute angles in terms of some known acute angles, we have found the values of trigonometric functions for that angles in the topic compound angles. Now in this topic, okay, transformation of sum and products, what we'll do, we'll find the, or we'll convert, okay, we'll convert the sum of two trigonometric functions of two different angles into the product, okay, or product of two trigonometric functions for different angles into the sum. Okay, that one we'll do in this topic. Okay, so the to learn or to know how to solve the problems related to the topic transformation of sum and products, we need to know all these eight formulas. Okay, so let me explain that formulas one by one. You see, the first one they have told sin c plus sin d. That means two trigonometric functions are taking different angles, sin c plus sin d. C and d are two different angles. So and they are in the plus, that means they are in the sum, sin c plus sin d, and we are supposed to transform this sum into the product. So how to transform? The thing is, sin c plus sin d will be equal to 2 sin c plus d by 2 cos c minus d by 2. We can see that in between two trigonometric functions there is product, but before that it was plus, sum was there. Now we have converted into product, okay, by this formula. So let us see how it is working. Suppose sine 25 degrees there, okay, and cos, let us not take 24, let me take 24 suppose, okay, and cos sine 24 degree plus cos 48 degree. These two angles you are given, okay, these two trigonometric functions you are given by their sum. Okay, now you are asked convert this sum into the product. So this one will relate with the, okay, that one will not be cos, that one will be sine. Okay, sin c plus sin d, that one will relate with the first formula, sin c plus sin d. In place of c there is 24, in place of d there is 48. So we can easily use this form, isn't it? Sin c plus sin d. So how to use? You see, we'll just put the values 2 sin c plus d by 2, that means 24 plus 48, 24 plus 48 divided by 2, then cos 24 minus 48, c minus d by 2. Just we have followed the formula, you see. So what we'll have, 2 sin 24 plus 48, it will give us what? 72, isn't it? 72 by 2, and cos 24 minus 48 will give us minus 24 by 2, isn't it? So 2 sin 72 by 2 will give you 36 degree, and cos, you see, cos of minus something we know already, cos minus x is giving us only cos x. We have learned in the first topic, cos minus x equal to only cos x. So cos of minus something will give you only the positive thing. So 24 is divided by 2, that means it is giving you 12 degree. So you see, in this way we have transformed the sin c plus sin d into the product one. You see, something product is there, is that it? So in this way we have transformed the sum into the products. So that is the topic. Now you can tell me, sir, how to remember the formulas, all these 8 formulas. These are means almost similar to one another, isn't it? Sin cos c plus cos d, c plus d by 2, that kind of. You see, the thing is, you will remember in this way. Suppose sin c plus sin d is there, sin c plus sin d is there, the first formula. We'll learn in this way, sin c plus sin d is equal to 2 sin sum divided by 2 and cos difference. Sin sum cos difference, we'll learn in this way. Let us not take divided by 2 also. We'll learn in this way, 2 sin sum cos difference. That means sin is taking the sum and cos is taking the difference if it is sin C plus sin D. If it is sin C minus sin D, then just the opposite, you see. Sin C minus sin D if it is, then cos is taking the sum, sin is taking the difference. We can see, isn't it? In the sin C plus sin D, 2 sin C plus D by 2. That means sin is taking the sum of the angles and cos is taking the difference of the angles. But in case of sin C minus sin D, cos is taking the sum of the angles and sin is taking the difference of the angles. Okay, so in this way we can remember the formulas. Okay, suppose for cos C plus cos D, it is very easy. Okay, in case of cos C plus cos D, cos will take sum, again cos only will take difference. Okay, both the things will be cos. Okay, 2 cos sum cos difference. We will learn in this way. Cos C plus cos D means 2 cos sum cos difference. In this way, 2 cos sum. Sum means the angle sum. Okay, and again cos difference. Difference means subtraction of them, isn't it? So cos C plus cos D is very easy. Now a little bit tricky is cos C minus cos D. Cos C minus cos D. In case of cos C minus cos D, both the things will come by sine. You can, and this is helpful also. You see, in case of both, if both the things are cos C plus cos D, if it is there, cos C plus cos D, both the things are coming with cos. In case of cos C minus cos D, both the things are coming with sine. But one thing you are supposed to note that in case of cos C minus cos D, sine is taking the sum, it's okay, but sine is taking the difference in some different manner. You see, in all the three, it is C minus D by 2, but here I have written D minus C by 2 in the reverse manner. That is, you are supposed to note down. If you want to write C minus D by 2 again, then you are supposed to give one minus in the beginning. Or if you want to write D minus C only, at that time you are supposed to take plus only. Okay, so better take D minus C by 2 in case of cos C minus cos D. Let me give one example. Okay, when to take D minus C by 2. Suppose the question is given cos 12 degree minus cos 36 degree. Suppose this question is given. Okay, in this case it is cos C minus cos D. No, in this form, the fourth form, it is coming under the fourth form. So cos C minus cos D is, what is the formula? 2 sin C plus D by 2. In the sum there is no problem. 12 plus 36 by 2. Okay, 2 sin C plus D by 2. Another one is sin only into sin. The thing is, if you take C minus D by 2, it will give some negative value. And as it is dealing with sin, so sin cannot absorb the negative. Minus is coming out. Minus is coming out because we know sin cannot absorb that. Sin minus x is giving you minus sin x. So that's why in that case we are supposed to take D minus C, because the larger angle minus the smaller angle will not give you any kind of negative thing. So at that time I'll write 36 minus 12 by 2 in the reverse manner. Or if you are writing in the same manner only, in the normal manner only, at that time you are supposed to give one minus, so that from that minus it making is plus. So better you take, in case of cos C minus cos D, you take 2 sin C plus D by 2 sin D minus C by 2. Just remember this one. I have given the star mark, okay, for this one. Now, what about the remaining 4 formulas? What about the remaining 4? Actually, the remaining 4 formulas are nothing. Just a little bit change in the first 4. We are getting the last 4 formulas. You see how? Suppose, I am telling you, suppose this 2. Suppose this one. C plus D by 2. Suppose we are considering this one is as the angle A, and this angle I am considering as the angle B. So we can read as 2 sin A, the full angle, cos B, isn't it? We can read like this, 2 sin A cos B. So 2 sin A cos B, this is the first formula, you see. 2 sin A cos B. So 2 sin A cos B, if 2 sin and cos is there, it is coming sin plus sin, no? So this is also like this only, you see. Sin A plus B plus sin A minus B. 2 sin A cos B. Sin A plus B plus sin A minus B. Remember that here A is greater than B. I am considering A is greater than B. Obviously, because A is the plus, no, and B is the minus. So obviously A will be greater than B. So in that case, if 2 sin A cos B is there, 2 sin A cos B, then we can write sin A plus B. Okay, because C means here, in that case C will be A plus B. Okay, sin A plus B plus sin A minus B, because plus only there. All the notations, all the trigonometric functions, all the things will be same. Okay, 2 sin A cos B. Similarly, the second one, you see, 2 cos A sin B, isn't it? Now cos is taking A. Now cos is taking A and sin is taking B, isn't it? If I consider this one as A and this one as B, now cos is taking A, sin is taking B. Okay, 2 cos A sin B. This is the second one. Okay, in that case, if cos is taking the sum and sine is taking the difference, that means cos is taking the bigger angle and sine is taking the smaller angle. So because obviously sum is the bigger angle and subtraction is the difference is the smaller angle, so cos is taking the bigger angle, 2 cos A sin B. In that case it will be sin C, means sin A plus B. Okay, sin A plus B minus sin A minus B, the thing will be minus. That is the difference, only difference is this one. 2 sin A cos B if it is, then sin A plus B plus sin A minus B. If it is 2 cos A sin B, if cos is taking the means bigger angle, at that time that one will be minus, that one will be minus. Now cos 2 cos A cos B is exactly same, 2 cos A cos B, isn't it? This is A, this is B, 2 cos A cos B. At that time both the things will be cos, both the things will be cos and will be plus. So that one only I have written cos A plus B plus cos A minus B, both the thing I have taken cos. Now in case of the last one, okay, in case of the last one, 2 sin A sin B, 2 sin A sin B, like this one, 2 sin A sin B, isn't it? 2 sin A sin B. At that time what I am doing, it is a little bit different. You see cos C minus cos D, that means cos something minus cos another thing. So that one only, cos A minus B minus cos A plus B. This is a little bit different from the other three. You see again, in all the other three, A plus B I have taken in the beginning, then I have written A minus B part. But in the fourth one, 2 sin A sin B formula, cos A minus B minus cos A plus B, that means minus part has been taken in the first, then plus is taken at the last. So cos A minus B minus cos A plus B. So I have discussed a little bit. Also you try to make some or means find out some trick to remember the formulas, or else if you go with the problems, by solving so many problems, the formulas will be automatically remembered. Okay, so these are the 8 formulas for the topic transformation of sum and products. So let me discuss the formulas, okay, by taking some problems. By taking some problems, that one would be helpful for you. So let us take some problems. Let us take some problems. So the formulas you are already having. Let me rub the formulas. I'll go by the problems. Okay. So the first problem of today's topic, that one is very important. You see, first question of today's topic, that one is sin 3 theta minus sin theta divided by cos theta minus cos 3 theta. Okay, that one is equal to cot 2 theta. We are supposed to prove this one. This one is equal to cot 2 theta. This one we are supposed to prove cot 2 theta. So we'll obviously go by the left hand side. Much more informations are there and we know the formulas as well. So if I take the left hand side, suppose I have taken the left hand side. Now in the left hand side you can see that sin C, suppose this one is C, suppose this one is D. So sin C minus sin D is there, no? So what was the formula for sin C minus sin D? Already I have given sin C minus sin D. If minus is there, sin C minus sin D is there, at that time 2 cos sum, cos is taking the sum. Okay, then sin is taking the difference. Like this, that one was the formula, sin C minus sin D. So we'll apply the formula here, sin C minus sin D, that means 2 cos, cos will take the sum, that means 3 theta plus theta, 3 theta plus theta, C plus D by 2, cos C plus D by 2, just following the formula, okay, into sin C minus D by 2, that means 3 theta minus theta divided by 2, that one I have taken, okay, in the numerator. Again in the for the denominator, it is cos C minus cos D, that one was the fourth formula, okay, different formula was that, star mark I have given, cos C minus cos D. In that case what will happen, you see, 2 sine, both the things will be sine, 2 sine C plus D by 2, okay, and another one is also sine D minus C by 2, just in the reverse manner, D minus C by 2. So what will happen, you see here, 2 sine C plus D by 2, that means theta plus 3 theta by 2, but in case of the next one sine, it will be D minus C by 2, you see, 3 theta minus theta, okay, divided by 2, just in the reverse manner. In which case, in case of cos C minus cos D, remember, in case of cos C minus cos D, the formula is 2 sin C plus D by 2 sin D minus C by 2, in that way. So just calculate a little bit. So what we are getting after calculation, if I take 3 theta plus theta will be 4 theta, 4 theta divided by 2, it will be 2 theta, that means 2 cos 2 theta into sine, you see, 3 theta minus theta, that is 2 theta, 2 theta divided by 2, again theta. So similar calculation is there in the denominator. We can take 2 sine 2 theta, okay, into sine 3 theta minus theta 2 theta divided by 2 again theta. You see, now try to see the cancellations. You see, sine theta is cancelled, 2 cancel. So what we are getting? Cos 2 theta divided by sine 2 theta. What it would give you? Cos 2 theta divided by sine 2 theta. Obviously the right hand side cot 2 theta. So we are getting cot 2 theta, and which is your right hand side, and hence proved. So this is the proving style. Okay, this is the style how we'll apply the formulas, okay, in the problem. So let me go with the second problem quickly. Let me go to the second problem. Okay, same type of second problem. Let me solve one more so that you can clarify your idea. Okay, the second problem is, second question is sine A minus sine B, okay, whole divided by cos A plus cos B, cos A plus cos B. This one equals to, we are supposed to prove tan A minus B by 2. Okay, obviously you are able to figure out the problem how to do. We'll relate like sin C minus sin D, sin C minus sin D. Already we know the formulas. If sin C minus sin D is there, sin C minus sin D is there, then minus, obviously just now we have used the formula sin 2 cos sum sin difference. If minus is there, it will start by cos, 2 cos sum, it will take the sum and sin difference into the sin difference, that means C minus D by 2, and in the denominator we can see cos A plus cos B. That one is the third formula, cos A plus cos B, cos A plus cos B. At the time that is very easy, both the things will be cos, 2 cos sum cos difference, that means cos A plus B by 2 into cos A minus B by 2. Both the formulas will apply here and we'll get our proof. You see how? You see here, if I apply the formulas, okay, sin C minus sin D, that means 2 cos sum, that means sum means sum of these two angles, that means A plus B by 2, into sin difference, that means A minus B by 2. Now in case of the denominator, cos C plus cos D, both the things are cos, 2 cos C plus D by 2, that means cos sum into cos difference. Cos difference means A minus B by 2. Now you see the cancellation, try to figure out the cancellations here. You see this part, okay, this cos A plus B by 2, cos A plus B by 2 got cancelled, 2 got cancelled. What we are having? Sin A minus B by 2 divided by cos A minus B by 2. You see the angles should be same. Sin A minus B by 2, the angle is A minus B by 2, and cos A minus B by 2, the angle is A minus B by 2. So sin theta by cos theta, we know tan theta. So that one will give you tan, in place of theta what is there? A minus B by 2, which is your right hand side. So this is the second problem. Okay, so this is the way how to solve the problems of transformation of sum and products of trigonometric functions. So let me take the third one. Let me take the third question. Third question, I'll try to solve 5 problems today, okay, related to the topics, 5 or 6, let's see. The third one, question 3. Question 3, they have told sin alpha, okay, plus sin 120 plus alpha, 120 plus alpha, plus sin 240 plus alpha, 240 plus alpha, okay, is equal to 0. That one we are supposed to prove as 0. You see, this problem can be solved using the concept of compound angle as well. Sin A plus B, that formula I have just discussed in my last video. Sin A plus B formula, sin A cos B plus cos A sin B. Sin A plus B formula, sin A cos B plus cos A sin B. That one also can be used, or the formulas of this topic, that is sin C plus sin D. Okay, that one also can be used. So let us use the formula for this topic only. We can solve by both the rules. Okay, as we can see that the first part, it is a simple angle, only simple alpha is there, but in the second two there are some different angles, so we'll take these two together. Okay, sin C plus sin D, this one will treat as C and this second angle will treat as D. So what will happen, you see, if I try to solve, so sin alpha is there only, plus if I take sin C plus sin D, so the formula was 2 sin C plus D by 2, that means C is 120 plus alpha plus D is 240 plus alpha divided by 2. Okay, that one I have taken 2 sin C plus D by 2, then cos C minus D by 2, that means this one minus this one, that means 120 plus alpha minus 240 minus alpha divided by 2. So the formula just I have taken. Then what will happen, you see, sin alpha plus 2 sin, will take a little bit calculation, alpha plus alpha 2 alpha, 120 plus 240, that is 360. So if I take again 2 common, okay, from the whole thing, and that 2 will get cancelled with the denominator. So 360 means it will be 180 plus alpha, isn't it? Because the numerator will be 360 plus 2 alpha divided by another 2 is there, no? So from the numerator, if we take 2 common, it will be 180 plus alpha, and that 2 will get cancelled with the denominator. Okay, that 2 will get cancelled with the denominator. So that is the thing we got in this way. Then cos, this part you see, alpha will get cancelled, alpha will get cancelled. Now 120 minus 240, another 120 minus 120, and cos is there, so minus will get diminished, minus will get vanished, isn't it? 120 minus 240 will be only 120, will treat as 120 divided by 2, that will be 60 degree. So it is coming cos 60. Minus is not coming because cos can absorb the minus. Cos can absorb the minus. Now we'll just put the values, you see. Sin alpha is there only, plus. Here we need to do a little bit concept of quadrant. We need to use. You see, 180 plus alpha. 180 means from here to this much. Then plus alpha. That means you are in the third quadrant. You are in the third quadrant. This is the house of 10, and we are calculating the value of sine. So it will be minus, obviously. So that sign, positive sign, will be changed by minus. Then as two 90s are there, so sine will remain sine only and alpha. Have you got? So 2 sine 180 plus alpha will be minus 2 sine alpha into cos 60 degree. What is the value of cos 60 degree? That is half, already we know. So this 2 and this 2 got cancelled. So what we are remaining? We are having sine alpha minus sine alpha. So sine alpha minus sine alpha is giving you 0, which is your right hand side. So in this way also we can prove. We can prove here also by using the compound angle concept, or we can solve using the concept of quadrant also in the beginning. Okay, here only we can use the quadrant concept. Here only we can use the concept of quadrant. So this problem can be solved by any one of the 3 rules: concept of quadrant, compound angles, or by this transformation of sum and products rule. Okay, very important problem, very important, this type of problem. So I'll suggest that solve so many problems, okay, related to the formulas. In this video I will not be able to show you all the problems, but the rule I am showing you, you go and practice at home a lot, okay, then only you will be expert. Okay, so the next problem, let me take. So this problem which I am taking now, that one will be as your home assignment. You try to do it at home, do it at home, you will be able to do that one, no problem. Okay, so the question is, prove that sin 5x plus sin 3x, sin 5x plus sin 3x whole divided by cos 5x plus cos 3x. Okay, this one equals to, you are supposed to prove tan 4x. Very easy problem, just use the formulas. You see, sin c plus sin d in the numerator. In the numerator the formula will be sin c plus sin d. In the denominator the formula will be cos c plus cos d. Just put the formulas, just take the little bit calculation, and you will get your right hand side, tan 4x. Very easy, try to do this one at home. Okay, the next problem, that one I am taking here. Okay, let me rub this one. This one is the home assignment for you. Okay, so the next problem is, prove that cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x, that one is equal to minus root 2 sin x. This one we are supposed to prove. Okay, we are supposed to prove this problem. Okay, cos this one is equal to cos this minus cos this is equal to minus root 2 sin x. So let us take the left hand side, obviously. So if I go with the left hand side, you can see same problem. You can do this problem using the concept of compound angle by breaking cos a plus b, that means cos a cos b minus sin a sin b. This one also cos a minus b, that is cos a cos b plus sin a sin b, by using that one also. But here we will solve this problem using the rule of this topic, that means transformation of sum and product. So you see, cos c minus cos d, this one is your c, this one is your d. Cos c minus cos d. What was the formula? Formula is what? The formula was with sine. Okay, the fourth one. Okay, the star formula, the star marked formula. Okay, cos c minus cos d, that is 2 sine c plus d by 2, that is 3 pi by 4 plus x plus 3 pi by 4 minus x, that one whole divided by 2. 2 sine c plus d by 2 and sine d minus c by 2, this minus this, so will be what you see, 3 pi by 4 minus x minus 3 pi by 4, that one will be, this plus will change to minus, minus x whole divided by 2. So that one is sine d minus c by 2. Okay, in the reverse manner, already I have told. So 2 sine, if I see x is getting cancelled, so 3 pi by 4, so it is 6 pi by 4, no, 3 pi plus 3 pi, yeah, 6 pi by 4 into 2, you got like this. Okay, sine 6 pi by 4 and 2 is there, so 4 into 2 like this. Then sine, here what is getting cancelled, 3 pi by 4, 3 pi by 4 cancel out. Sine, what is there, minus 2x by 2. You see now, here what we can cancel out, this 2 is getting cancelled by this 6, that means 3 pi by 4. So we are getting 2 sine 3 pi by 4, 3 pi by 4 into, you see, this minus will come out of the sine because sine cannot absorb the minus, and this 2 will get cancelled. So we need to give one minus in the beginning, isn't it? This minus has came from there, so it is remaining only sin x, only sin x. Now we need to break this one using the concept of quadrant. Okay, using the concept of quadrant. So how to break, you see, how to break this part, you see, we can do this one by keeping in radian as well. Okay, or you can convert this pi into degree, then also you can find. Okay, so minus 2 sine, let me do it by keeping in radian. I can write 3 pi by 4 like pi minus pi by 4, no, that one I can write into sin x is there, into sin x. Now you see this, in this part I will use the quadrant concept. What is the concept of quadrant? You see, pi minus pi by 4, pi means from here to this much, minus pi by 4, that means you are in the second quadrant and you are calculating the value of sine, you are in the house of sine, so will be positive. How many 90s are there? 2 90s are there, that is even, so sine will remain sine only. So 2 sine pi by 4 will be there into sin x. Okay, so now see, let me put the value of sine pi by 4. What is the value of sine pi by 4? 1 by root 2, no, 45 degrees, sine 45 degrees, 1 by root 2 into sin x. So root 2 can be cancelled out, this 2, so that one will be root 2. So what we are getting, minus root 2 sin x, which was our right hand side obviously. So this is the thing. Okay, this is the thing. So here I have taken some problems. Okay, mainly I have focused for the first 4 formulas. Okay, I have taken. Some more problems can be taken using the last 4 formulas. Okay, using the same, just we will use the formulas. Okay, so in this video this much only. In my next video I will try to take some more problems using the last 4 formulas. Okay, that one I will take in my next video, and also in that video I will try to introduce the topic multiple angles. Okay, that one is our next topic, multiple angles, after the transformation of sum and products. Okay, so thank you.